Okay, in this lecture, I want to show you an example on how we can design a band reject filter by active circuit, active components such as op-amp. Now, in this example, we are allowed to use capacitor values equal to 0.5 microfarad, and this is the Bode plot of the band reject filter that we are looking for. So we have the Bode plot. The first step is figuring out what is our filter cutoff frequencies and what is the gain of the filter. So first I have to extract this data and information from the Bode plot, and then I can see if I'm looking at a broadband filter, I can follow the steps that we discussed in previous lectures. So the first thing that I can see from this Bode plot is the gain. The maximum gain is equal to 10 decibel. So my gain is equal to 10 decibel. And it means that the maximum standard gain is equal to 20 log base 10 of my standard gain, maximum standard gain. I have to solve this in order to find my standard maximum gain. So in order to solve it, I'm going to divide everything by the coefficient of log. So I'm going to have 10 divided by 20. It's going to be 0.5 equal to log base 10 of H max. And it means that my H max is equal to 10 to the power of 0.5, which means my gain is equal to radical 10, which is approximately equal to 3. So my standard gain is equal to radical 10 or 3. Remember that the decibel gain is not what you are looking for. The gain that you need for the first step of your design is the standard gain. So if you have the decibel gain, you have to convert this gain into standard gain. Now the next thing that we need is the cutoff frequency. So I need to know what is omega C1 and what is omega C2. What I have to do is that I have to find my bandwidth. So based on this plot, I can find my bandwidth, I can find my center frequency and cutoff frequency. So we know that the cutoff frequency happens at -3 decibel lower than my maximum gain. So because my maximum gain is 10 decibel, by subtracting -3 decibel, I'm gonna have 7 decibel. So it's somewhere around here. Let's assume that this is my 7 decibel gain. So the cutoff frequencies will happen at this particular gain. So it means that my lower cutoff frequency is equal to 100 and my higher cutoff frequency is equal to 1000. And if I'm looking for omega naught squared, that's equal to 500. And the difference between these two are going to be my bandwidth, which is 1000 minus 100, and that's equal to 900. So here I'm looking at two cutoff frequencies which are equal to 100 and 1000. I can consider them as widely separated. So it means that the smaller cutoff frequency is going to be your low pass filter cutoff frequency. So the cutoff frequency of your low pass filter is equal to 100. And your high pass filter cutoff frequency has a cutoff frequency equal to the higher cutoff frequency of your band reject filter, which is equal to 1000. I'm gonna write the information that I have from this page in another slide, and then I'll start working with them. So I know that omega C2 is equal to 1000, and it should be the cutoff frequency of my high pass filter, and that's equal to 1 over RH multiplied by CH. I know that the cutoff frequency of my low pass filter should be equal to omega C1, which is 10. So 1 over RL multiplied by CL should be equal to 10. My gain should be equal to 3. And I know that I can use C equal to 0.5 microfarad. So having all these equations and numbers, I can easily find all the parameters I need for designing purposes. So since I have, the first step is choosing the capacitor value. Here the capacitor value is given. So by replacing CH as 0.5 micro, which is my available capacitor, I'm gonna have RH equal to 2 kilo ohm. And again, on the second equation, if I replace CL by the available value, which is 0.5 micro, I can find my RL, which is going to be 20K. So here is my RH, here is my RL. The next two parameters that I need to find are RI and RF. So I can choose one of them. Let's say I select my RI to be 1K. Then according to the gain, RF should be 3K. So these two together satisfy the ratio that I need for the gain. So that's all I need to do. And this is the way that I can design a band reject filter by having widely separated cutoff frequencies. Now at the end, circuit is this one. And what I have to do is replacing the parameter with what I have. So the RL that I ended up having was 20K. CL and CH, both of them, let me delete them. CL and CH, both of them are equal to 0.5 microfarad. And RH was equal to 2K. So what I have for RH here is equal to 2K. I selected my RI to be 1 kilo ohm and my RF to be 3 kilo ohm. So this is going to be my band reject filter, which has cutoff frequencies equal to 10 and 1000 with a gain equal to 3.